In this video, we're going to use ScriptableObjects to store our player data in a clean, flexible way. Before we start using this asset in our project, let's take a moment to understand how a ScriptableObject is actually structured and why it's such a powerful tool in Unity6. A ScriptableObject is basically a container for data that lives outside of your scenes. Instead of storing player stats inside a player prefab, or inside a MonoBehaviour that resets every time you hit play, a ScriptableObject keeps that information persistent and reusable. You create it once, save it as an asset, and then any script in your game can reference it. In our case, we're creating a ScriptableObject that holds all the core stats for our player character. At the top, we have the Create Asset menu attribute. This simply tells Unity to add a new option in the Create menu, so we can generate this asset with a single click. It doesn't affect gameplay, but it makes the workflow much smoother. Inside the class, we define all the data we want to store. For example, we have a player name, the maximum health, the movement speed, the jump force, and even the attack power. These are all simple fields, but the important thing is that they're now centralized. If we want to tweak the player's speed or health later, we don't need to dig through prefabs or scripts, we just edit the asset. We can also store more complex types. Here we have two audio clip references, one for when the player gets hit, and one for the attack sound. We also have a particle system for the hit effect, and even a sprite that could be used as the player's icon in the UI. And ScriptableObjects can hold collections too. In this example, we have a list of starting items, a potion, a helmet, and a sword. This is a great way to define loadouts, inventories, or any kind of customizable setup. Now, something important. ScriptableObjects are meant to store data, not behavior. They're not a replacement for monobehaviors. They shouldn't run physics, input, or anything that depends on the scene. Think of them as a database entry, not a character controller. Another thing they should not contain is state that changes every frame. For example, you don't want to store the player's current health here if it's going to be modified constantly during gameplay. To create our ScriptableObject, all we have to do is go to the project window, right-click, and choose Create Player Stats. Unity instantly generates a new asset for us. The nice part is that we can edit every value directly in the inspector. Now let's create a simple stats component that will live on our player object. We reference two ScriptableObjects here, base stats, which holds the original values we set in the inspector, and runtime stats, which is the version we'll actually modify during gameplay. This keeps our original data safe while still letting the player take damage or get buffs. And at the bottom, we have a non-health changed event. This will let other parts of the game react whenever the player's health updates, for example, updating the UI or triggering a hit animation. It keeps everything clean and decoupled, instead of hardwiring logic directly into the player script. Inside the awake method, the first thing we do is create a runtime copy of our ScriptableObject. We use instantiate base stats, so we are not modifying the original asset. This is really important, because ScriptableObjects are shared by default, and we don't want every enemy or every scene to suddenly change the player's stats just because they took damage once. Then we have the take damage method. Here we simply subtract the damage amount from the player's current health. We also make sure it never goes below 0, just to avoid negative values. After updating the health, we trigger the on-health changed event. This sends out both the new health and the original max health, so anything listening like the UI or a health bar can react immediately. And finally, we log the value to the console, which is always useful for debugging. So this small block of code gives us a clean, safe way to modify the player's stats at runtime, without ever touching the original ScriptableObject asset. Now, just drag the ScriptableObjects we created into the player's fields, so the component knows which stats to use. Now let's drop in an enemy so we can test our damage system. Any GameObject works. I'm using a skeleton from the Unity asset store, but feel free to use whatever you have. Just make sure your enemy has a collider set to his trigger. Without that, it won't be able to detect the player and deal damage properly. Create a new C# script for the enemy. We'll use it to handle the basic logic for dealing damage to the player. Here's our simple enemy script, and its job is straightforward. Whenever the player enters the enemy's trigger area, the enemy deals damage. At the top, we have a do damage value, which represents how much health this enemy will remove from the player. Inside, on trigger enter, we first check if the object we collided with has the tag player. This keeps the enemy from damaging anything else in the scene. If it is the player, we try to grab the player stats component, and if that component exists, we simply call take damage and pass in the damage amount. This triggers the whole health update flow we set up earlier, including the event for the UI. If the component isn't found, we log an error, which is a good safety check in case something is misconfigured. So this tiny script gives us a complete interaction. The enemy detects the player, applies damage, and the rest of the system reacts automatically. I'm going to update the icon inside our scriptable object. This just makes it easier to spot the player data while we are testing. Now let's set up the UI, so we can actually visualize the player's stats during gameplay. Start by creating a new canvas from the Unity UI menu. Inside it, add an image that will display the player's icon, the same one we assigned in our scriptable object. This helps make the interface feel more polished and gives us a quick visual reference for the player. Next, add a slider to represent the player's health bar. I'm using a custom, nicer looking slider I grabbed from the Unity asset store, just because it fits the style of my project a bit better. But you don't have to do that. The default Unity slider works perfectly fine. The functionality is exactly the same, so feel free to stick with the built-in one if you prefer. Before we continue, remember that to access UI components like slider and image, you need to import the Unity UI namespace at the top of the script. Otherwise, none of these fields will show up correctly in the inspector. Now, inside our UIManager, we are going to initialize everything in the start method. The first thing we do is set up the health slider. We assign its max value based on the player's maximum health from the scriptable object, and we also set the current value to that same number. This means that when the game starts, the health bar is full and perfectly synced with the player's stats. Next, we subscribe to the player's on-health changed event. This is a really clean way to keep the UI updated without constantly checking values every frame. Whenever the player takes damage, the event fires, and our UIManager will automatically update the slider. It keeps the code modular and avoids unnecessary dependencies. After that, we handle the player icon. If the scriptable object contains an icon, and in our case it does, we assign it directly to the player icon image component. This gives the UI a bit more personality and makes it easier to identify the player visually. Now let's look at the update health UI method, which is the function that gets called every time the player's health changes. This method receives two values, the current health and the maximum health. Inside it, we simply update the slider's max value and its current value. This keeps the health bar perfectly synchronized with the player's stats at all times. Now that the UIManager is ready, let's hook everything up. Just go back to the canvas, select the UI elements, the slider, the fill image, the player icon, and drag them into the corresponding fields in the script. In play mode you can see everything working. The player icon shows up in the top left corner, and as soon as we walk into the skeleton, the health bar starts dropping exactly like we set up. Thanks for watching, I hope this helped you out. Make sure to subscribe to the channel so you don't miss the next Unity tutorials coming soon.